All right, here's a continuation of operations with complex numbers. Recall that expressions in simplest form cannot have square roots in the denominator. Because the imaginary unit represents a square root, you must rationalize the denominator that contains the imaginary unit. To do this, we need to multiply the numerator and the denominator by the complex conjugate. So the complex conjugate, so if we have a complex number in a plus bi, the conjugate, all you do is you change the sign of the imaginary part. So notice we have an addition symbol and then a subtraction symbol. So those are considered complex conjugates. So first example says we have a complex number in the numerator, 3 plus 8i, and then in the denominator we have another complex number, negative I. And we want to multiply the numerator and the denominator by the denominator's conjugate. So here's the denominator. The complex conjugate, if you have a negative I, then the conjugate would be a positive I. So you do that to the numerator and the denominator. Now we're going to go ahead and simplify. So simplifying it is just like what we did in our previous lesson where we used the distributive property. So I'm just going to change the order. I'm going to put I first, and then 3 plus 8i. And then in the denominator, I'm going to put I and negative I. And now we're going to distribute. I into 3i is 3i. And then I into 8i is 8i squared. In the denominator, I times negative I is negative I squared. Now just like in our previous lesson, when you see an I squared, you replace it with a negative 1. So this term is going to become a negative 1, and this piece will become a negative 1. So we have 3i plus 8. We replace that I squared with a negative 1. Replace that I squared with a negative 1. And then continue simplifying. So up in the numerator, we have 3i. And then 8 times negative 1 is negative 8. And then in the denominator, negative 1 times negative 1 is positive 1. And then to put it in standard form, we have the real piece plus the imaginary. Now notice that this is a dividing by 1, so when you divide by 1 and divide by 1, you can go ahead and just remove those. So now it's in standard form. It needs to be the real part plus the imaginary part. Second example, we have a complex number dividing a complex number. So what we need to do is identify the denominator and what is its conjugate. So if I have 4 minus 2i, the complex conjugate would then be 4 plus 2i. So that's what we're going to multiply the numerator and the denominator by. So I'm just going to rewrite that as 2 plus 8i times 4 plus 2i. In the denominator, I have 4 minus 2i, and then 4 plus 2i. So just like in our previous lesson, we need to multiply the complex numbers together. So we're using the distributive property, and we nickname that the FOIL method, first, outside, inside, last. So 2 times 4 is 8. 2 times 2i, 4i. 8i times 4, 32i. 8i times 2i is 16i squared. Go to the denominator. Again, FOIL. First is 4 times 4 is 16. outside. 4 times 2i is 8i. Inside, negative 2i times 4, negative 8i. And then negative 2i times 2i is negative 4i squared. One thing that will always happen when we multiply by complex conjugates here is you'll see these middle terms cancel out. And then just like our previous problem, when you see an I squared, we replace it with a negative 1. So we have an I squared here, we have an I squared there. So those we were replaced with negative 1. So continue simplifying. We have 8 plus, and now notice these are like terms. So they will condense down to 36i plus, and then we can replace that I squared with negative 1. In the denominator, we have 16 minus 4. We replace the I squared with negative 1. Continue simplifying. So we have 8, and then 16 times negative 1 is negative 16, plus 36i. In the denominator, 16, and then negative 4 times negative 1 is positive 4. Again, we have like terms and like terms. So we simplify. 8 minus 16 is negative 8, and then plus 36i over 20. That is the complex number simplified, but you could go farther by reducing the fraction. So what I can do is I can factor out in the numerator a 4. So I have negative 2 plus 9i, and then the denominator is still 20. The reason why I did that is I could then reduce by a common factor. I can divide the numerator and the denominator by 4, so that becomes a 1 and a 5. So what's left is then negative 2 plus 9i over 5.